Here we are looking at example 3D from our 4.3, 4.4 set of notes. We're asked to factor the following. And just looking at this, we do notice that we have 30x squared plus 5x minus 10. We notice that we have a trinomial here. And we're going to go ahead and try and look at our step one, that greatest common factor. And when we look at these three numbers, we do notice actually that they are all evenly divisible by the number 5. So in this case, we do have a greatest common factor. It is 5. They all are evenly divisible by 5. So if we have 30 and we divide it by 5, again, because we pulled it out, we end up then with 6x squared. If we have our 5x and we factor out a common factor of 5, we end up then with just positive 1x. And then if we have that factor of negative 10, and we factor out 5, we end up then with negative 2. So again, just factoring a 5 out of all three terms, we end up then with 6x squared plus 1x minus 2. Next, we're going to look and see, do we have a trinomial that can be broken down into two different binomials? And that's step 2, those two different binomials. Well, the 5 just carries down. He doesn't go away at all. And then we create our two different parentheses. Just looking at the number 6, we notice that this is not a prime number, so we have to create a small list from it. What times what gives us 6x squared? Well, 1 times 6 would accomplish that. Likewise, 2 times 3 would accomplish that. And again, typically we try and stick to two numbers that are a little bit closer together. So we might go with 2x and 3x. Now looking at the list for 2, that last number 2, we have 1 comma 2. It's a nice prime number. When we try and dump it in here, we'll go ahead and maybe throw the 1 here and the 2 here. Let's just see what happens with that. Again, we don't necessarily know, but we're just kind of testing things out. So the 5 just drops. Here we get our 6x squared. That checks out. When we multiply the outer, we end up then with 2x. And then when we multiply the inner, we end up with 6x. Finally, the last, we get 2. Unfortunately, when we try to combine these in any way, we do not get the positive 1x that we were hoping for. So let's go ahead and just try maybe swapping the 2 and the 1. Let's have the 1 here and the 2 right there. Well, when we distribute again, the 2x times the regular 2, we get positive 4x. And then the 1 times the 3x, we get 3x. And can we in any way combine the 4x and 3x to get 1x? We totally can. Looks like this would have to be a positive 4x, and this would have to be a negative 3x. So kind of working our way backwards again with the signs, this would have to be a positive to get the positive 4x. 2 times the 2x, get the positive 4x. And then this guy would have to be negative, because again, we had to have negative 3x. Negative 1 times positive 3, we get our negative 3x. So it looks like our final answer comes out to be 5 times 2x minus 1 times 3x plus 2. And this again is our final factored form. Again though, that is example 3D from our 4.3, 4.4 set of notes.